Good morning and a warm welcome outside there to the US from Germany. At my side, my dear colleague and good friend, Daniel Brown. How are you doing today?
Good man, good. Chris, good to see you here as well.
Thank you, thank you. Yes, my name is Chris. I'm also doing pretty good today. As we see in Germany, it's around pretty late right now and it's getting dark. So you are at the start of the day, we are at the end of the day, but still we are happy to be here with you guys and giving you a good show. On what? What's the topic of today?
So today's webinar is actually the second webinar that we're running. So yesterday we did ASE and today we're going to have a look at hybrid electric vehicles with in a particular focus on the ASE L3.
Okay.
So having a look at the specialist test that's been around for a few years now, and we're going to have a look at not just the L3, but we're going to have a bit more of a deeper dive into the technology today as well. So looking at how the electric vehicles work.
Perfect. And this will be followed by tomorrow's webinar then, which is focusing what?
That's then going into high voltage batteries. So that's really then a deep dive into the electric vehicle. So
hot shit.
Yeah. So even though this one's going to be having a look at things like three-phase motors. So we know three-phase motors work without brushes, things like that, induction motors, permanent magnet motors. We know that they run with three phases or three-phase electricity, which is usually AC. We have batteries, of course, so how do we get that AC from DC sources?
So more or less a complete look on the high voltage system of a certain car. We have, different examples for that, and you will see how this very complex and new topic will be introduced by our training systems. So talking about high voltage system and high voltage cars, I mean, what is the challenge and what are the demands? There are people outside who are experts on high voltage, like you are, for example. There are people who have done a little bit with it, and there are also a lot of people who haven't touched high voltage.
Yeah, absolutely. So it's obviously a big challenge. We're talking about automotive technicians, so actually we haven't introduced ourselves. Maybe you were on the webinar last night. Daniel Brown, originally from Australia, automotive technician with Toyota, and then got into teaching as well. Was a customer of Lucas Nuller in Australia, buying the equipment that you see here. Ended up working for him as well. So,
and
Chris,
now
You've just achieved your 10 years here in the company as well.
That's right,
Congratulations.
Even if do not look that old, maybe.
Wow.
So that's right. I'm now for 10 years here in the company and being part of the team for the product management for automotive. I come more from the study university side. Daniel is more the mechanical, the hands-on guy. And this is what we have done more or less the last 10 years, that we have, focused and combined our powers and energies and just did the best out of it.
So what's been really interesting here with Christian as an engineer, so don't be shy, you've got your engineer qualifications.
Think so, yeah.
What that helps is I've got the practical background, you've got more of the theoretical, so what we're able to do is then understand a little bit more deeply how this topic really comes about, because we're talking, a lot of the things that we're talking about for hybrid electric vehicles are outside of the vocabulary for automotive guys.
That's right,
We start talking high voltage. Electricians normally deal with high voltage. We start talking inverters, things like that. So obviously a lot of electronics. So it's good where we can sort of combine our skills and competencies to put together the e-learning and the hardware to do that. But today we're not doing a sales pitch. We really want to do some training for you here. We'll do a live Q&A probably towards the end, I would say. Otherwise, so it doesn't break down at all. But if you got any questions, you can write them down anytime. And if we see them, we'll go through and answer them on any particular topic that we're covering at the moment.
Absolutely.
The webinar, as long as you guys stay around, we could be here. So I'd say we need at least an hour, but we could go for 2 hours. So we'll see how we go.
Perfect.
Talking about the challenges though.
Yeah, exactly. So I
just,
when we're talking about these things, I just have to remember Skills USA last year, for example, where we have been with our training system or with our trainer, which we'll see later, the ASE L3 trainer. What was very what was very important for me to see that there were, of course, there were some students, everyone did pretty well, but there were students who were like, high voltage, yeah, I did a lot with that. And there were a lot of students who were really shaking in front of it, and they were like, wow, never touched high voltage before. And you could see that they were basically afraid.
Yeah.
So this leads me to the question, we have here brand new vehicle, Audi Q5 hybrid. So basically, we have here a car with a combustion engine, with bus systems, with driver assistance systems, and with a complete high voltage system. So why shouldn't we use just that car for doing this ASE L3 trading?
Well, if you have a look at it, and we'll go into detail what that L3 task list is. So not everyone's seen the PDF that you can download from ASE yet. We'll go through that and show you what is required to pass the test. But if you have a look at a real vehicle, especially late model vehicles like this, it's getting harder and harder to see what's actually going on inside. So this is an Audi hybrid, and essentially what we can see here, which gives us any indications that it's high voltages, we've got a couple of stickers here, and I can see at the moment one orange cable. So the electric motor would be down the back here. Battery is hidden away in the back of the vehicle.
Absolutely.
And when it comes to really understanding, so there's certain things we can sort of train people up in order that they can do something, a particular task, or we can train them up so that they understand. And I think, I spoke about this last night, and I'll say it again because we don't have the same people that are here, but I can really say the German philosophy when it comes to training, we all know about the German apprenticeship system, the dual system that they talk about, where the word apprentice means that you get a job first, you start working on the job, and then you begin your training. And there's a whole, there's a very long history of apprenticeships here in Germany, and there's a real focus on making sure the young person that's getting trained gets trained completely. So they're not being trained for one particular job,
yes,
as in one particular job of a certain trade. They're really learning the whole trade. So there's a deep, understanding of the systems, and that's what they call system understanding. And so that's what we try to bring into our training systems here at LN.
And now, as you said, especially it's absolutely about this deep understanding, this getting the whole picture of it. But especially if we are talking about hybrid electric vehicle and the high voltage system, and you even said, okay, we're going to touch the high voltage battery even later on, or basically tomorrow in this webinar. But what about how would you describe the challenge on such a real vehicle when it comes down to the high voltage safety?
Yeah.
Especially when someone is touching it who has no idea of it, and then you have even one teacher, one instructor, and he has to take care of 10 people, 20 people, and you maybe have 1 or 2 cars. So what is the challenge there if we are talking about the safety aspects when it comes down to hybrid electric vehicles?
So obviously we're talking real high voltage. So on a vehicle, you've got the batteries. Batteries are now running in anywhere between 100 volts to that new Hummer that we looked at.
Yeah, I just thought about it.
800 volts. So 800 volts DC, that's massive. You short circuit that, there's going to be some issues. But even the most common vehicles we see now, the Prius, the Leaf, things like that. Tesla. Looking inside the batteries, yeah, of course, we've got real high voltage there. But you've also got the problem which vehicles are not made for training. So they're not really designed. They're designed to be safe, actually.
Of course.
So they put layer upon layer of safety on top of them. So of course there's interlocks, so that if you inadvertently open something, they shut down, which is good. But they deliberately cover things as well. They make sure that they're covered with, the battery is always usually sealed somehow. And so you've got to do a lot of work to the vehicles to get access to them, and which, it's not a bad thing. And we have plenty of vehicles out there where you do a lot of preparation to make sure, in training colleges and things like that. But if you start doing that with hybrid electric vehicles, are you accessing places that are safe or not? Obviously, also taking measurements. We can't take any measurements really easily or safely on the three-phase motor to see what the signals look like as well. So, if you start pulling apart cables
Yes.
or worse, probing three-phase high voltage cables could be a little bit of an issue.
That would be definitely a big problem.
Yeah.
So what I see so far now is like, okay, when we want to learn something about hybrid electric vehicles and we are using such a car, at the first step, it's very hard for us really to see the high voltage system. When I have no idea of what the high voltage system is, for me, it's very hard to understand how this is integrate into the car, because it's basically hidden.
Yeah.
The high voltage cables are running under covers, for example. It's not like that you always can see them. As you see, the main idea of the car manufacturer is to hide everything which is orange, so that the normal customer, the normal driver can't touch it basically. It's also a problem about when we are talking about training on hybrid electric vehicles, it's always about doing diagnosis and repair on it. So here's another question then. I know it from earlier times when we have combustion engine cars or just normal test engines. It was easy to put in some faults, for example, like the mass airflow sensor was broken or the lambda probe had a problem. You just did a bad wiring, a bad connection or anything like that. Now we are talking about a high voltage system where we have, like we said before, up to 800 volts, hundreds of ampere running through the system.
Yep.
I can imagine that the connections between the single high voltage components are not just normal connectors like you know it from a 12 volt system.
No, sir.
And I also can imagine that it's a little bit problematically when you just put faults or simulation, when you want to simulate faults inside the high voltage battery, for example.
Yeah, absolutely. So obviously the connectors, they're not just simple pull apart connectors. So they're surrounded by something called an interlock. And we'll go into a little bit more detail about what an interlock is and how that works as well. So if you pull the connectors apart, they usually got big long connectors inside that will displace or pull apart the interlock before you pull apart the high voltage. So that is a sign to shut down. So that will, for example, open up the system main relays, which is something we'll also have a look at later.
Absolutely.
So then on the other side, you've got the problem that not a lot of scan tools are keeping up with electric vehicles now. So we've had plenty of schools over the years that have bought hybrid or electric vehicles, and they've got a scan tool, but it's not up to date and it doesn't have those vehicles. So if you put the faults in there, you can't access that vehicle and then delete the codes. So there's workarounds for that, but it's a bit of a pain. And so
basically you need the tester by the car manufacturer directly really to get a deep look into the system and get a deep access to it basically.
And what I do want to say here though is that we're not trying to replace the vehicle. You still need the competency to fix the vehicles. What we are trying to do with our training systems is show or to teach the students a little bit more knowledge.
And we roll out the red carpet towards the car basically,
Exactly.
so that they can go it when it's not about being in fear of hybrid electric vehicles, it's being respecting them basically. Know what the dangers could be, but also knowing when I keep up with the safety rules, I'm more or less, there's no 100% guarantee that everything works fine, but basically when you keep up to certain rules, then you're on a very good side that you can easily operate and do diagnose on these kind of cars.
So your example was good about Skills USA, and I've heard this from other teachers as well, not just at Skills USA, but so we had students. Skills USA, I'm sure you're all familiar with. This year would have been our 4th year with the section station, hybrid and electric vehicle safety. And we've had students every year so far, and these are the best of the best, don't forget. So this is the national program at Louisville. We're still getting students that are removing service plugs without the gloves, They look at the gloves, they have no idea what are the correct gloves, what are the wrong gloves, the measuring devices, all these sort of things. And so that was a real wake-up call for us. Some of the best students, and we've got the document right in front of them that tells them what they need to do.
Yeah.
And so it kind of shows me that when they're going out to the real world, get their jobs, and then they're going to be under even more pressure. You've got the service managers saying, look, we've got to get this car out, or they get given, all of the gloves or no gloves. Do they understand what they need to do before they get out in the real world? And so,
as you say, yes.
What we're trying to do is kind of give or impart a culture of safety so that they know and understand before they get to the real cars what they need to do.
So in other words, it's so important for them. Even you can give them the handbook where it says word by word what you have to do. In a situation where you are under pressure, where you have time pressure and all these, all day things which happen to you or which have an influence on you, even there the best handbook won't be of much help if you have not the fundamental knowledge which will tell you what you have to do, that you know how you can protect yourself, how the high voltage system of a car principally works, and how you can do different measurements on the car.
Yep.
And on top of that, of course, the car manufacturer specific informations, you have to read them and to use them. But as you say, the most important thing is to create this culture of safety by creating a correct knowledge base, fundamental knowledge base, where you basically can touch every high voltage car without bringing yourself or someone else in dangers. I just thinking about that, especially we are talking here about cars in a good condition.
Yeah.
It gets even more interesting when we are in a certain situation at the workshop situation short before the end of the shift. So everyone is looking for the home time, and then a car or tow truck is coming and just bringing up a damaged Prius or something like that. It's not like before that you just can say, okay, bring it into the workshop, we take care of it tomorrow. There are real issues which we also will see later and even tomorrow.
Yeah, so that is talking about creating some confidence in the student as well. And so, excuse me, the teachers, so we've got a lot of these units in the US, and we're getting a lot of teachers are telling me what they do, right, is the students, when you're working on a real vehicle, so the shutdown procedure, which we'll go into detail about, there's a step where you need to do a live, dead, live test. And that's where things get serious, because you have to really measure the live high voltage somewhere on the vehicle. So that's changing a little bit with newer vehicles. That happens internally, but with most vehicles on the road, there is a point where you can measure the high voltage. And when you've got a classroom full of usually, young men,
powerful men,
it's can be a bit of a worry when you've got, say, 16 of them in your class. You have to watch that guy like a hawk on what he's doing. And sometimes we get a little bit overzealous telling them, don't mess this up, like this is real. All of a sudden, we've got the feedback I'm getting, the students, and now all, they're shaking as they're doing that. So we don't want that as well. We don't want to scare them. We want to give them the confidence. And so teachers are putting the students in front of the car train here and saying, just do it 20 times. Get used to what are the gloves, what are the measuring devices, doing the one hand rule, live, dead, live testing and things like that. So
many points which you basically have to know.
Yeah.
So basically when we sum up, so at the real car, basically there is everything, but everything is there in a way which makes it hard to train.
Yeah.
So we have talked about interlock stuff, we have talked about the setup of a high voltage system, we have talked about the single components of a high voltage system, how you can identify a high voltage system, doing repair and diagnostic tasks on a high voltage system, and of course the most important thing, doing the disconnect procedure. Mm-hmm. There are certain ways of doing that right now out on the road at the different cars. So the question is now, it's hard to bring that across through a real car. So what will we see now? How we can solve these issues, and how can we teach that in a very safe environment, not on the car? So, but where are we doing it?
Yep. So I think we've talked long enough. So we'll go over and have a look in our high voltage area here now.
Exactly.
So this is what we've set up as our high voltage area. So, for example, in Germany here, there's very strict rules about setting up the any high voltage battery, for example.
Absolutely.
There's very strict rules as far as having it set up with bunting in its own room where people can't access. There's licensing that's required for who can work on the various stages. So it's not just split up into working on high voltage vehicles. There's people who might be just involved with a high voltage vehicle full stop. Then there's people that can shut down the high voltage vehicle, and then there's people that can work on a live high voltage vehicle, as in working on the battery, for example.
Yeah.
So, but this is what we've got here. Couple of different systems. We've got what we call a truck train here. So we've got
heavy duty vehicles.
Yeah, heavy duty.
Just go out of the way.
And that's because that's becoming a huge thing at the moment as well, talking about hybrid and electric vehicles that are coming in on the heavy vehicle. The one we'll be focusing on mostly today is this one here, the car train. So the systems here, these ones are very similar. So looking at, this is kind of like the introduction to hybrid and electric vehicles. And the one that we'll be going into detail, we'll have a look at a few things on this one today as well, but we'll be going into much detail with this one tomorrow, is the high voltage battery. So this one here might look like it, but is actually a high voltage battery there. The 70 volts, high voltage is considered 60 volts
DC, 30 volts AC.
Exactly. So what I'll have a quick look at though is just for everyone who hasn't seen it before. So I'll just share the screen up here so we can bring that up. Is what the ASE L3 test looks like. So you can get this. You can get this simply online. So go to ASE or search it, ASE L3, and it'll come up straight away. Super easy to find. Goes through, as you're probably all aware, the task list, the questions, everything that you need to know. And this one here, this is the task list. So there's 5 different areas that are being focused on.
That's true.
And what I've just pulled out here is having a look at, now I always call this blue, but I'm colorblind, so more of
it's
pinky,
purple, blue,
blue,
it's okay.
Purple, blue, you get the idea. What it is, these are over and over again throughout the whole system. So, and it's split up into 2 sections. So we've got a safety section here, perform high voltage disconnect procedure, reconnect, enable high voltage system. Select, test and use proper safety gloves, select, qualify and use proper electrical testing equipment and leads. That's under the battery section, it's under the drive system section, and power electronics and the hybrid supporting system. The exact same thing, rewritten
over
four
again.
times.
Yeah.
Obviously we don't have internal combustion engines, and we're not going to cover combustion engines here whatsoever, because I think most of you
are experts on that.
As well.
Yeah.
If we have a look at the yellow system here, it's now retrieve and diagnose DTCs, diagnostic trouble codes, determine needed repairs. Diagnose problems caused by damaged or failed harnesses, connectors, terminals and fuses, and test, diagnose and repair high voltage leaks or loss of isolation. And again, that's over and over and over again looking at that. So there's a couple of standout points there. Safety, of course, is paramount. They're saying understand what gloves you're wearing, understand the measuring devices that you're using, and be able to shut down the system.
Yeah.
If we look at the technical side, retrieve and diagnose DTCs, determine needed repairs. Now, I love that. That's how many words? 7 words. In order to diagnose something, you need to know so much though. It's a different thing just saying diagnose something, but in order to diagnose something, you really need to understand it. And so that's where the theory that we've been talking about before really comes into play.
Absolutely.
So understanding the system is absolutely required at this point in order to diagnose. Isolation. Isolation using insulation testers is a huge point here. So obviously we've got a separated system or an isolated system. The high voltage system doesn't run on the normal chassis system. It has its own circuitry within the vehicle. So if you've got a breakdown of insulation, you're going to have a bad day. So
that's true.
Having that high voltage system onto the chassis. So that's called a loss of isolation or insulation. So we'll do a test there. And that also comes into failed harnesses, connectors, terminals and fuses there. So obviously, so we've got a bunch of equipment here.
The so-called PPE.
Exactly. So
what I really liked about it, and this was also one very important task of the Skills USA, they look all the gloves. So we see here gloves, we see rubber gloves, we see leather gloves, I see measuring leads, and I see different multimeters, let's say that way. So on the first view, everything looks pretty much the same. So basically, when you tell me now, just go there and have a look at it.
You could imagine that's what you could find at the
Absolutely,
store or at a workshop. Someone just gives you a box of gloves and says, okay, go and fix this car.
Absolutely. And the question now for me is, I mean, we are all aware of that we are working with high voltage. So we need a certain level of safety there. So that means that this one, it's like the last defense line, right? In front for the high voltage system, basically. So all the components must be at least able to block the voltage, which could possibly come from the high voltage system, from the car, wherever. So we have to fulfill certain requirements. What are the requirements for this PPE then, before we touch the high voltage system?
What I'll do is I'll just bring back the screen here so we can see. So this is the LabSoft course that we have, which goes with this. And so this goes through the complete theory that's required. So
and that's basically built on the ASE L3 curriculum, right?
It's literally, if we have a look at that ASE L3, we see here battery systems, internal combustion engines. As I said, we'll leave that out. Drive systems, power electronics, hybrid supporting systems. If you see here, we've got the main chapters are literally battery systems, power electronics, hybrid supporting systems. Drive systems is a part of the power electronics. But this is exactly, and we've added introduction. So we want to talk about why do we have electric and hybrid vehicles? And of course, safety has its own chapter there as well.
Okay, yeah.
So if we go to safety there, we talk about risk assessment and things like that as well.
Just one thing, but because I just see it, and we have also repetition for the electrical and electronic fundamentals. As I can imagine that this is very important if you want to touch high voltage, which is on a very high level, speaking of electricity and electronics. So this course also offering like an additional chapter when you see that your students are a little bit, let's say, that it makes sense to repeat some of these topics. That means all the fundamental topics which you need in order to understand the high voltage is in there. You can do it or you can leave it out.
Yep, absolutely.
That's cool.
And that works. We would rather err on the side of caution, add more information than's necessary. So it's just like reading a book or a textbook. You know, you can skip some pages if you don't need to cover that in this class.
So I have talked to a teacher and he basically said, wow, what is great about this e-learning courses that you have created, there is a lot of content and you can't do it on 2 or 3 days. But what he loved so much about it is the fact that you do not need additional sources. So basically all the information you need in order to understand high voltage system is inside this e-learning.
Yep. Okay, so talking about gloves before, so we can go through here and we can show exactly what gloves the students need for hybrid electric vehicles. So the information there is about class 0, 1000 volts rating, and also there needs to be a testing that needs to be done as well. And so that's what we recommend here. We've got all of the different gloves, and that's by design. We do that deliberately, basically to confuse the student, but we're forcing them to make a decision.
Okay.
And so we're giving them the wrong gloves, we're giving them gloves with holes in them, things like that, so that when they go to this point, testing the gloves, they understand, okay, are they choosing the right ones and things like
Yeah.
that.
Shall I do that for that now? Because later on we need them for
So I'm quite conscious that we've been talking for quite a long time already and we haven't shown anything. I mean, there's a lot to talk about, but what we might do right now, I think, is we'll do an insulation fault on the system.
Okay.
And we'll perform a shutdown.
Yeah.
And an insulation test at the same time.
That's now a very good thing about this. We said before, putting high voltage faults inside a real car is very, very dangerous because you basically can't see and can't understand how the car will react. In the best case, the car just breaks down. In the worst case, the car's catching fire. Everything's possible basically. So that's why you never should manipulate a high voltage system by your own. Furthermore, we have also experienced another problem that was here in Germany, very, very interesting. If you are talking about shutdown procedures, so shutdown procedures are a good method, or a lot of schools or training centers are using that like a test to see if the student has understood the most important task on this car. So, and the thing was there, of course, you don't have just one student doing it, you have a couple of students doing it, and maybe even in a row. So it's like shut down, set it up again, shut down, and you're just going in circles about that. And what has happened here in Germany during a test, they have used a Prius 3, I guess, when I remember correctly, and there they had 10 students, and of course the car was before heavily in use, so they did a lot with the car and shut it down pretty often. And what happened during the test suddenly, that they shut down the car, and for the last 2 students, they want to put it back into operation, and suddenly the car said, stop. You have shut down me now so often in a row, so there must be some really critical issue when there is a need to shut down the car so often behind each other. So what the car did was like, I'm doing nothing anymore. He just, the control units for the board network and all that just shut down and did nothing on that anymore. And basically they have to call Toyota in order to set the car back into operation. What is great about this system, what I've seen so far, you can shut down it as often as you want and nothing happens, right?
Yeah, absolutely. So a little bit of an introduction to the system. This is what we call our car train system. And so what we're seeing here is a way to simulate different types of hybrid and electric vehicles. So we've got a little overview of the different types of hybrids that are available. Things like series, parallel, or series parallel. So series would be something like a range extender. Parallel is like an electric motor, like the old Honda systems with a boost mode, for example.
Okay, yes.
Series parallel is then your Toyota systems.
Prius.
Yep. And electric vehicles and fuel cell vehicles.
Okay, and what have I to do now? Do I have to dismount everything to get from the one system to another system?
No, so what we've got here is just systems where we can change out this overlay mask, and what we can see here is how the system,
this one?
Switch that out. And just by plugging in this plug here, we can then identify that as an electric vehicle instead.
So on the whole the whole monitor changed here, and now we see the setup of an electric vehicle.
Yep. So you can see here, this is kind of like the breakout box. This is what we were saying before, where it's a little bit easier to be able to see and take measurements within a high voltage system. So once we've got the system going, we can go through, and what's interesting here, it probably would have been better if I had that one left on there actually. We're looking at how we've got energy flows within the, maybe we'll just switch that back again because electric vehicles are a little bit boring when it comes to energy flows.
That's right. So you see you can do everything on the fly. The system do not crash.
Without that, it goes back to a combustion engine just to see what it's like. But here we can see what different types of hybrid systems are. When do we get generation through MG1, MG2, what's driving, what's regeneration, using extra systems under acceleration, things like that. So this is what we call the car train, and this is what we're using. This is kind of our introduction to hybrid electric vehicles.
And what can I do? I see now I have a fully charged battery now. So, I mean, it's not fully charged, it's inside the state of charge, basically. But when the teacher now wants to have 50%, what should I do?
So you can switch that down quite easily here and see what happens under lower state of charges. When does the MG1 come in to generate a bit of extra power for the system?
And it's the same here with that system. That's always a very interesting point. So when we are talking about 99 or 100%, it doesn't mean that we are using the full capacity of the battery, but that it's used in a certain window. For example, between 30 and 80% of the real capacity of the battery.
Yeah, and that's where, I mean,